Hi, my name is Tarun. Hope everyone is doing well here today. In this video, let's learn about how to generate the object code for the given SIC/XC source program. So this is the source program given, and for this object codes, the numeric values are also given out here. So what we need to find out is the location counter values for these instructions, and then using these location counter values, we can generate the object code over here, and using these object codes, we can generate the object program as well. So basically there are four kinds of instruction, which is type 1, type 2, type 3 as well as type 4. If an instruction is kind of type 1, then it occupies one byte of size, and if it is type 2, 2 bytes, if it is type 3, 3 bytes, if it is type 4, then 4 bytes. So let's start with generating the location counter values for this instruction. So here the program has been starting with the address of operand value of 3000. So we need to take out the first instruction values. Location counter will be 3000. So the first instruction contains a register which indicates that it's a type 2 instruction format, so we need to add 2 bytes to the location counter. So that is why which is written as 3002. And if we look at the next instruction, which does not contain any kind of register over here, so it is considered as type 3. So we need to add 3 bytes to the location counter, which makes it 3005. And if we consider the next instruction, it consists of a plus symbol over here, which indicates that it is a type 4 instruction format. So we need to add 4 bytes to the location counter value, and this does not contain any kind of location counter value because it is an assembly directive. Here if we consider this instruction, it does not contain any register over here, and it also does not contain any plus symbol over here. So it is of instruction format type 3, so we need to add 3 bytes, so it is 3000C. And if we consider the next instruction, here it's the same, which is of instruction type 3, so we need to add 302 over here in location counter value, so it is 3000F. And if we consider the next instruction, of instruction format type 3, so we need to add 3 to it, so the value of the location counter will be 3012. If we consider the next instruction, it's of type 3, so we need to add 3 bytes, so it is 3015. Even this instruction is of type 3, we need to add 3000, we need to add 3 bytes, so it is 3018. Now if we consider the instruction reserve byte of 2000, so 2000 words is equivalent to 6000 bytes. So if we can convert this 6000 bytes into hexadecimal, we get 1770. So we need to add 1770 to 3018, which we get 4788. So the next instruction is of reserve word 1. So one word which is equivalent to 3 bytes, so which we need to add 3 bytes over here, which is 478p. So this is how you can generate the location counter values. Now let us generate the object for this equivalent instructions. Now let's generate the object code for the given instruction. So the first instruction we need to consider is the clear, which opcode value is b4. So in this case, the clear instruction is of second instruction format. So the first 8 bits are of opcode, and the uh, next 4 bits of register R1, and next 4 bits for register R2. In this case, the opcode value for clear instruction is B4. So B4 comes it's in the opcode value, and then the value of X is 1, so 0001. So the object code for this instruction would be B410. So now let's consider the next instruction, which is LDA, where the opcode value is 00. So this LDA is of third instruction format, so the first 6 bits are reserved for the opcode, and the next 6 bits are reserved for the flags, and the next 12 bits are reserved for the displacement value. So we need to consider the 6 bits for the opcode, so which is of 0000 and 00. So this instruction is of immediate addressing mode, so I set to 1 over here. So the So the object code for this instruction is 010000. Considering the next instruction, which is of fourth instruction format and it's of immediate addressing mode, the opcode value for this instruction is 68. So 68 can be written in the binary value as 0110 and 1000. So since we need to consider only 6 bits for the opcode thing for the fourth instruction format, so it is considered as 0110 and 10. Since this instruction is of immediate addressing mode, so I is set to 1 and E is set to 1 because it's of in fourth instruction format. So in the address for this is 4788. So the hash total is indicating over here where its location counter value is 4788. So this thing is considered as 4788. So now the object code for this instruction would be 6910169110. Now let us generate the object program for this object code. So the object program contains three records, which is header record, text record, as well as end record. The header record is, so the column 1 of the header record contains the letter H indicating the header record. Then the column 2 to 7 indicates the program name. In this case it is SUM. And then the column 8 to 13 indicates the starting address of the program, which is 3000. Then the column 14 to 19 would be the length of the object program in bytes, which is 178B. Next, text record. The column 1 of text record is the letter T, and then from column 2 to 7 would be the starting address of the record, which is 3000. And then the column 8 to 9 is the length of the object code in the record in bytes. Then the column 10 to 69 would be the objects code whichever we have generated in the previous slides. Then finally we have the end record, which is the column 1 indicates the letter E, which indicates the end record, and then the column 2 to 7 indicates the address of the first executable instruction.